I would like to start this video by asking a question that I'm pretty sure that most of you will get wrong. So let's go over and look at this. Here we've got a beaker or a glass full of ice water. I want you to imagine that the ice is all spread out evenly. I couldn't really draw it very well that way, but just imagine that there's finely crushed ice all over in this water. So if you stick a thermometer in it, that's going to read right here at 0 degrees Celsius. Most of you know that already. But here's my question. My question is, what if we add a heat source? And I'm just going to draw a candle to represent a heat source. If we add a heat source, what is going to happen to the temperature as time passes? Well, what you're going to get wrong is that you're going to say, oh, well, the temperature is going to go up. And in the future, that's true. The temperature is going to go up, but it's not going to go up right away. What's going on? As time passes, the temperature hangs around right here at 0. And it's kind of hard to get that to happen because you know the ice likes to float to the top, and so you'd have to stir it. But if you can keep this mixture, if you can keep the ice spread out in the mixture, what happens is this graph stays flat. So why does it stay flat, and for how long does it stay flat? Well, it stays flat until the heat source has melted all the ice. So once all the ice is gone, then the temperature can go up. So right now, the temperature stays, I'll go back to the red line here, it stays around 0, and then, once this ice is all gone, then our temperature can go up. Okay? So that's the question that most likely a lot of kids get wrong. So let's carry this a little bit further in time. Let's say we've got our heat source here. I mean, who cares if it's one heat source or a bunch of heat sources? We keep adding heat. How high does this graph go? Does it go up forever? Well, the answer is no. No, it doesn't go up forever. What happens is the temperature goes up until you hit 100 degrees, and then it does this again. It stays flat again. So what's happening at that time is something else. Down here, where we're adding all this heat, the water is turning into a gas. So you start to see these bubbles. We call it boiling. So these bubbles rise up, and what's happening is the energy from the heat source is going into changing this water into a gas. So these little particles of water, these little water molecules are jumping out, and eventually our water level would go down. So as long as we don't put a lid on this, you know, if we try to contain it, as long as we don't put a lid on it, then all the energy we add is just going to go into boiling the water. Even if we added, you know, lots more heat, what would happen is our water would just boil more quickly, but our temperature would still stay at 100. So by now, maybe you've guessed that these weird flat parts of this graph, these are the reasons why I'm making this video. And they are called, those flat parts are related to something called latent heat. Okay? Latent is an old word that means hidden. So there's hidden heat going on in this graph. And that goes back to why a lot of you guys got the first question wrong. We add heat, and it didn't go into raising the temperature. The temperature stayed the same, even though we were adding heat. So right here, when the graph is flat, we've got latent heat going on. And up here, where the graph is flat, we've got latent heat going on. So when did we say that the temperature started to go up? The temperature started to go up when all we had left was liquid. Okay? And the temperature was flat when we had the ice, which is a solid, and we had the liquid water that it was in. So we had two states right here where it was flat. Likewise, up here when we were boiling, we've got liquid here, and we've got the little gas bubbles. So this flat spot, we had liquid and gas. So what's going on here? The energy that we're adding right here is going into melting. So the latent heat is going into melting the ice on that flat spot. And then over here, the latent heat is going into boiling. So the boiling of the water accounts for the latent heat there. So that accounts for this notion of latent heat. What I want to do next is I want to talk about this graph going backwards. So I'm going to clear this space out over here. And I'm going to draw a new graph. And I want to think about this one, this graph right here. This was all about adding heat. We were taking our sample and we were putting heat in. But what if we have a sample and it's cooling off? Well, if we have a sample that's cooling off, then that means heat is going out. So that would be a graph that is going down. So we could have a graph that looked like this. Let's say we start with a sample that's in this neighborhood right here. So we've got a liquid and it's cooling off. We're going this way. So if I'm going to start my graph right there. If we have a sample that is cooling off, then it is going to be losing heat. Okay? And once it gets down to its freezing point, whatever that is for the substance you're talking about, here we're talking about water, but what happens is at this point, while the water's freezing, the temperature will stay at that temperature. And it's possible to, you can take ice and cool it below freezing. So if you go and snoop around Google or whatever, and you'll see graphs that have like all these different chunks on them. There's like 1, 2, 3, 4, 5 different legs on these graphs. That's more than I wanted to do in my video. So what about this that's cooling off? So I went out and I Googled, I typed in heat packet here, and I got this guy who just opened up this liquid pouch thing. It's got some kind of a liquid in here. And let's watch this just for a few seconds. There's a little hunk of metal in here he's going to use to upset the liquid. And when he does that, it's going to start to grow crystals. And there you can see the crystals are growing. And what does that mean? I'm going to pause it for a second. So right now, this bag is half full of liquid, half full of solid. So we're going from the liquid state down to the solid state. So what happens over time? This thing is going to feel warm. That's why they sell these things. They're little heat packs. Okay, so let's go back to my graph here. What's going on there? Well, that's actually, that substance is actually, we call it supercooled, but for the purpose of this video, we can not worry about that. What's happening is you're taking a liquid. Why is it showing the eraser? Okay, I was holding the pen backwards. Anyway, so we're starting off with a liquid, and the liquid has given away its heat, and we've actually gotten down into this neighborhood here. And when he upsets that little sample, what happens is all that heat goes out, it leaves, and that's why the packet feels warm to us. So these graphs can go forwards or backwards. I already showed you other people's graphs, and we already talked about the states of matter on the graphs. What was important there was that wherever the graph is flat, you're changing state, so you've got 2 states, and wherever the graph is tilted, you're just heating something up or cooling it off, and you've only got 1 state of matter there.